Hi class, today we're going to start looking at inductive proofs. Right here we have our normal summation symbol where I is an element of n, and over here our equation n times n minus 1 over 2. Okay? Base case, n equals 1, and here 1 is going to equal the equation we have. So 1 equals 1 times 1 plus 1 over 2.
So I have a question.
Go ahead.
What is the base case?
So the base case is where we're going to start. So right here under the summation symbol, I equals 1, this is where the index starts.
Okay.
All right, so after we complete this, we're gonna go on to our inductive hypothesis. We're gonna set n equal to k. From there, we have our steps. We're gonna take the summation k plus 1, I equals 1, and we're gonna set it equal to the summation of k, I equals 1, and then I plus the parentheses of k plus 1. Yes, what's your question?
Why does n equal k?
So that is just our hypothesis that we are testing.
So listen, right? K times k plus 1 divided by 2 plus k plus 1 equals k plus...
Honestly, I really don't know what's going on today. We were supposed to be learning inductive proofs, but we had like 3 different teachers. They just kept popping in. Every time I look down, there's someone new. I'm just a senior. I'm trying to graduate. I'm getting my last credit, and then I'm out of here.
K plus 1 times k plus 2 divided by 2. So therefore, proven by mathematical induction, n times n minus 1 divided by 2 is true.
Who are you people?
So overall, I think we had a great day today. You know, we taught a lot of students proofs by mathematical induction. I heard there was a confused student there saying she saw multiple teachers, which was very weird because I was there the entire time teaching. Besides that, it was a great day. Everyone learned.
So we have the equation n factorial is greater than 2 to the n, for n is greater than 4. The base case that we have is n equal to 4, so we have 4 factorial, which is equal to 24, is greater than 2 to the 4th, which is equal to 16. For the inductive hypothesis, we're going to say that the statement is true for n equals k, so we have k factorial is greater than 2 to the k for k is greater than or equal to 4. For the inductive step, for the first part, we are going to multiply k factorial greater than 2 to the k by k to the k plus 1 on both sides. So we're going to have k plus 1 k factorial is greater than k plus 1 2 to the k. And for our second step, we have k plus 1 factorial, getting rid of this k, is greater than k plus 1 2 to the k. And then we end up with 2 times 2 to the k equals 2 times k to the 1. And k plus 1 factorial is greater than 2 to the k plus 1. So therefore, by mathematical induction, n factorial is greater than 2 to the n for when n is greater than 4.
All right, class. So we're going to go over this new proof here, and we're going to prove that 1 over n times n plus 1 equals n over n plus 1. So we're going to use a base case, and for n, we're going to make n equal 1. We get 1 over 1 times 2 equals 1 over 2, right? Because 2 times 1 is 2. But that's also going to be equal to 1 over 1 plus 1. So using inductive hypothesis, assume that n equals k. Wait a minute. Shit. I think I fucked it.
He swore in class.
Oh my god, he swore in class? Josh, how old are you?
I'm 21.
You're 21? Then get it together, man. Jesus Christ. Where was I? Okay, so 1 over 1 times 2 plus 1 over 2 times 3 is essentially what k is going to be representing. Because if you look at here, 1 over k times k plus 1 plus 1 over k plus 1 times k plus 2. So that's going to get... Josh, if I turn around and that's you on your laptop, I swear to God, we're going to have some problems.
It's how I take notes on my laptop.
You're disturbing the class, Josh. That's strike 2. Okay, where was I? I apologize, class. Okay, so, damn it, Josh, equals k over k plus 1 plus 1 over k plus 1 times k plus 2. That's gonna equal k times k plus 2 plus 1 over k plus 1 times k plus 2. Now, Brandon, do you know what comes next? Of course you don't, because you failed the last test, okay? I don't see you writing any notes at this point. So follow along. It equals k squared plus 2k plus 1 over k plus 1 times k plus 2. All right? That's going to get then equal to k plus 1 squared over k plus 1 times k. Josh. One more, and you're done. It's over. Now, we're towards the end of the problem, all right? You're gonna hold it together? It's gonna equal k plus 1 over k plus 2. Therefore, the statement is true if n is equal to k plus 1. Any questions? Brandon? You're failing the semester, it doesn't even matter. Class is dismissed.